Hello everyone. So in this video, we will be discussing circles. So circle is a set of all points on a plane that are equidistant from a fixed point on the plane. And in circles, the fixed point is called the center, and the distance from the center to any point of the circle is called the radius. So now, let's start with the discussion of the circles with the standard form of the equation of a circle. So the standard form of the equation of the circle is given by the formula x minus h squared plus y minus k squared is equivalent to r squared, where h and the k here are the points the for the center. So, for example, we have here find the standard form of the equation of the circle whose center is at 2 and 1 and whose radius is 2. And now draw the circle. So from here, from the example, again, H and K is the center points. So meaning to say our center points are our H and K is 2 and 1. So transforming this one to our standard form of the equation of the circle, so we have x minus 2 squared plus y minus 1 squared is equivalent to r squared, which is 2 squared. So performing the operation of this one, so we have x minus 2 squared plus y minus 1 squared is equivalent to 4. Now, it is said that we have to draw the circle. So, from a Cartesian plane, let's say we have this Cartesian plane here, and it is said that the center of our circle is at 2, 1. So, we need to plot that one in our Cartesian plane. So, let's say we have 1, we have 2, 3, 4, 1, 2, and 3. We also have 1 and 2, 1 and 2. So again, our center is at this point at 2, 1. This is the center of our circle. And as we know, the radius of our circle is 2. So say you need to count 2 points after the center. So we have 1 and we have 2. And also this one, we have 1 and we have 2 and we have 1 and 2. So this is this one. Then we have 1 and we have the 2. So probably if you try to draw the circle, then it might look like it might look this one. So assuming this is a perfect circle, everyone, so we have circle of this one. So this is our circle, and the radius is this one. This is 2 and this is 2. At any point in the circle, so if we try to draw our points, or if we try to draw our circle, we have from our Cartesian plane, we have 1 and 2, 3, 4, 1, 2, 1, 2. So let's try to draw our circle first by plotting the center point, which is at 2, 1. Then, as we know, the radius is 2, so meaning to say, you need to count 2 points after the center. So we have 1 and 2. We have 1 and 2. It's probably here. It's probably here at this point. And then we have 1 and 2. So it's somewhere here. 1 and 2. It's somewhere here. Now let's try to draw our circle. So probably this is what our circle looks like. So it is said that the radius is 2. So any points or any points in our circle from the center that is equivalent to 2. So that is for the standard form of the equation of a circle. Now let's move on to the next slide, which is the example, another example. Find the standard form of the equation of the circle whose center is at 1, 0, and which passes through the points -1 and -1. So as you can see, radius is not given anymore. So meaning to say we need to solve for the radius. So from the formula of the standard form of the equation, we have, again, if you can remember, we have x minus h squared plus y minus k squared. That is equivalent to r squared. Now, we can use the data points that we have here in order for us to solve for the value of our radius. So, that being said, we can use the equation, this one, we can use this equation. So we have -1 minus 0 squared. So we have x sub 2, this one, minus x sub 1. So I'm sorry, this should be 1 plus y sub 2, which is this one, -1, minus our y sub 1, which is 0. So if you equate that one, that is r squared. But since we are looking for the radius, then we need to square that both sides. So if you try to calculate this, our radius is equivalent to square root of 5. So meaning to say we already got the radius. Now we need to find the standard form of the equation of the circle. So we need to put it back to this equation. So we know that the center is 1 and 0, meaning to say 1 is the h and 0 is our k. So again, we have x minus 1 squared plus our k, which is y minus 0 squared, is equivalent to square root of 5 squared, right? So that being said, we have x minus 1 plus y squared, because this is 0. So if you expand that one, the remaining term is just y squared. And we also have our square root of 5 squared, that is equivalent to 5. So meaning to say, this is already the standard form of the equation of our circle. Now, if we try to plot that one again to our Cartesian plane, so let's say we have our Cartesian plane here. And again, the center is at 1, 0. So we have 1 and 0. And then we have our radius is equivalent to 2.5. So we have 1, 2, and half. And then let's try to plot our center first. So we have 1, 0. So that's somewhere here. And then we have 1, 2, and 2.5. So we have 1, 2 and 2.5, 1, 2, and 2.5. So probably our circle is about here, 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 and here. So let's try to connect these red dots to form a circle. So probably our circle looks like this. So the radius is the half of 5, which is 2.5. So this is now what our circle looks like. So now let's move on to the next topic, which is the equation of a circle with center at the origin. So unlike earlier, unlike the previous slides, the center was not plotted in the center of the Cartesian plane or the origin of the Cartesian plane. Now we will be talking about the equation of a circle with center at the origin. So if C or if the center HK is equivalent to 0, 0, then the equation of the circle is equivalent to x squared plus y squared is equal to 3. Is equal to r squared. So this is now the equation of our circle if the origin or if the center is at the origin. So for example, find the equation of the circle whose center is at the origin and which passes through the point 2 and 1. So as we can see from the problem, radius is not given here, so we need to solve for the radius first. So in order for us to solve for the radius, we need to use the data points or the points that we have here in our problem, which is the origin or 0 and 0, and we have the 2 and 1. So we need to use that one. So we have x sub 2, which is 2, minus x sub 1, which is 0, plus our y sub 2, which is 1, minus our x sub 2, which is 0 squared. That is equivalent to r, and then square root of this. Basically, it's just the same with the distance formula. It's just that in circle, it is called the radius. So if you try to calculate this one, r is equivalent to square root of 5. So if you try to calculate this, you'll get the result of square root of 5. Now afterwards, since we are looking for the equation of the circle, then um, we need to substitute that to our equation of the circle. So in this time, we have x squared plus y squared, which is equivalent to our r squared, which is square root of 5, and that is squared. So we have the equation of our circle is x squared plus y squared is equivalent to 5. So this is already our equation of the circle. Next is the general form of the equation of the circle, which is given by this equation. We have ax squared plus ay squared plus dx plus ey plus f. So the capital letters there are constant numbers in our equation of a circle. So for example, we have here reduce 4x squared plus 4y squared plus 4x minus 12y plus 1 is equivalent to 0 to the standard form of the equation of a circle and find the coordinates of its center and radius. So for this one, we need to reduce tau this equation to the standard form. So again, the standard form is x minus h squared plus y minus k squared is equivalent to r squared. So right, if you can remember, this is the standard form of the equation of the circle. So now from this equation, we need to reduce that one in order for us to form to this equation. So let's start by rewriting that here. So afterwards, as you can see, the constant numbers are divisible by 4. So let's just divide all of this by 4, or we can multiply both sides by 1/4. So that gives us x squared plus y squared plus x minus 3y plus 1/4 is equivalent to 0. Now let's just move the constant outside the move the constant to the other side of our equation. So we have x squared plus y squared plus x minus 3y is equivalent to negative 1/4. Now, the problem is asking for us to find the coordinates of the center and the radius. So first, we need to find the coordinates first, or we need to solve for the coordinates of our center by completing the square method. So before we conduct the completing the square method from this equation, we need to combine like terms. So we have the x squared plus x. We also have plus y squared minus 3y is equivalent to 1/4. As we know, by completing the square method, we need to find the b and then divide it by 2. So in this case, from this one, this is our b, which is equivalent to 1 divided by 2 and then square. So that gives us 1/4, right? Now for this one, this is our b. Negative 3 is our b. So that's negative 3 divided by 2. And then you need to square that. So that is equivalent to 9/4. Now afterwards, after you get that, you need to add the value of your b to your equation, right? So that gives us x squared plus x plus 1/4 plus y squared. It's just like you are conducting, or you are solving for completing the square in two equations. So we have y squared minus 3y plus 9/4. That is equivalent to negative 1/4. And again, for the completing the square, whatever you add to the equation to the left side, you also need to add that to the right side of our equation. So that gives us 1/4 plus 9/4. So as you can see, negative 1/4 plus 1/4, that is equivalent to 0. So from this one, we need to find the factor of this one and as well as this one. So we have x, and for the tip here, whatever uh, you have here from this one, you have 1/2 here and you have negative 3/2 here. So that's the factor of your um, equation. So we have x plus 1/2 squared, and the other one is y minus 3/2 squared. If you try to expand this one, this will give the same result as this. The same as this one, it will give the same result as the equation that we have. So we have 9/4. So as you can see, this is already transformed to this form, or to the standard form of the equation of the circle. So meaning to say, we've already succeed with the with our goal to reduce this formula to the standard form of the equation of the circle. Now, it is said here that we need to find the coordinates of its center. So meaning to say, the coordinates is 1/2 and negative 3 halves because this is our h and this is our k, right? And for the radius, we need to find the radius. So you just have to square 9 over 4. Radius is square root of 9 over 4. That is equivalent to 3 halves. So this is now the standard form of the equation of the circle. This is our center coordinates and this is our radius. So that's it for this example. And that's it for this video. I hope you learned something from this video. And I'll see you on the next videos. Thank you very much. Please don't forget to like the video.